reasons why chemistry students fail chemistry or they're generally not good in chemistry is because they overlook the fundamental topics. They didn't get the fundamental topics. So when the hard one comes, it gets hard to grasp the concept. So in this video, I'm going to explain or simplify one of the most fundamental topics in chemistry, that is atomic structure. Now, I'm going to be making a series of videos for A-level content, A-level chemistry content, so you better subscribe to this channel so that every time I make a video and I post a video on YouTube, the YouTube algorithm will notify you. This is the typical illustration of an atom. Now, an atom consists of a nucleus and energy levels or electron shells on which the electrons will be orbiting in around the nucleus. Now, the nucleus consists of subatomic particles that are namely the protons and the neutrons. Both the protons and the neutrons are called the nucleons. So we will have our nucleons consisting of protons plus neutrons. So to find the number of protons given the number of the nucleons and the neutrons, that will be simple math since we have already established this particular equation. Now, the electrons, they'll be orbiting around the electron shells or the energy levels. So that will be it. Our subatomic particles, let me just put it, the protons and the neutrons. The protons, they have a mass. Each proton has a mass of 1 atomic mass unit. Okay, that's the mass. They're going to put the charge over there. Like that. So our neutrons, we have protons, mass of 1, a charge of positive 1, neutrons, a mass of 1, a charge of 0. Then electrons, the mass is so negligible that some consider it to be 0, but in actual fact, it's 1 over 1840, and the charge is -1. So now, if we have an atom, suppose that's X, with the nucleon number A and the proton number Z. The proton number will represent the number of protons that are present in the atom as well as the number of electrons. So the proton number is equal to number of electrons. Then this is called the mass number or the nucleon number. Take for example, if we have let's say magnesium. Magnesium is an atomic number of 12. The atomic number is also the proton number. So let me just put it right there. Atomic number. That is also the proton number. So it has a mass. It has an atomic number of 12 and a mass number of 24. That means the mass number 24 is also the nucleon number. So the number of nucleons that we have here, we have 24 nucleons. That means we have 24 nucleons. The 24 constituents of the protons and the neutrons that exist within the nucleus, as we have already established that these subatomic particles, they exist in the nucleus. Then atomic number is 12. The atomic number is 12. That means we have 12 protons, we have 12 electrons. So number of electrons is equal to 12. Number of protons is equal to 12. That means the number of neutrons, if we substitute into that equation that we established above the that is the nucleon number, or the nucleon number is equals to the proton number plus the neutron number. I'm just going to represent my particles using these letters, the N and the P, so that I don't spend much longer writing this. There we have it. So our nucleon number is 24. Our protons is 12. That means our neutrons, we put there, becomes 24 minus 12, and give us the number of neutrons is going to be 12. So for magnesium, we're going to have, in the nucleus, we're going to have 24 nucleons with 12 protons and 12 neutrons. Well, it's such a coincidence that the number of protons are also equal to the number of neutrons. In some atoms, that is not the case. So don't just assume that the number of protons will be equal to the number of neutrons, but rather use the equation that we established before, that the number of nucleons is equal to number of protons plus number of neutrons. Then the electrons, the number of electrons will be equal to the number of protons. So here they coincide, we have 12 protons. And that's it. So we have established that. We also need to understand how these subatomic particles behave in a magnetic field and in an electric field. Now, in a magnetic field, it's not so hard to deduce, since we've already established that the protons are positively charged. In an electric field, they'll be deflected to the negative terminal, and the electrons, they'll be deflected at the positive terminal. So that's not so hard to deduce. For example, if I have my electric field here, and this is connected to the positive terminal, this to the negative or earthed. If I put a beam of subatomic particles here, the neutrons will not be deflected because they have a charge of 0. The protons will be deflected towards the negative. Then the electrons, they will be deflected towards the positive. And the deflection of the electrons is so much greater because their masses is less. So it's easier to attract them because they have a lesser mass. They're lighter than the protons. Therefore, they can be attracted much more easier. As compared to the protons are much more heavier than the electrons, so it will be a bit harder to attract them, or rather to divert their path towards the negative terminal. Now, in a magnetic field, okay, let's say my beam of subatomic particles is going to come this way, right? And the neutrons, they won't be affected because they don't have any charge. Now, the protons, they have a positive charge, so their behavior, it will be likened, or it will be similar to that of conventional current. So we're going to use Maxwell-Corkscrew rule, that is the Fleming's right-hand rule. I prefer the Fleming's right-hand rule. Here it is. This is my right hand. I just form a fist like that with my thumb right out like that. Then the X, they just tell us that the magnetic field is going into the paper. So my thumb is going to represent the magnetic field that is going into the paper. And the curling of my fingers, it will represent the direction of the positive charges. So as you can see, the curlings, they are going in that clockwise direction, as you can see. So my protons, they're going to be deviated in that positive direction. Those are my protons. Then the electrons, like that. Now, we already established that the protons, they are much heavier, so their deflection will be much more harder as compared to the electrons. So that is the behavior of the subatomic particles in both magnetic fields and an electric field.